Right, guys, watch out for examples involving square roots. There's some very, very important principles. Many matrics get this wrong, and we need to focus. Just let's have a look at the side. I want you to consider the expression root x. Now, square root of x. Remember, if you square rooting a negative, that's called non-real. If you square root a positive number, that's real. But there's some other important glitches with this thing. If you have a look at this slide, root of x is real if the number under the root, if the dude under the root is positive or equal to 0. So an example, we square root of 0, 1, 2, 6, 7.5. Those are real numbers. The square root of a positive is very real. But now look at this. Now look at this. If you've got the square root of x is non-real, this happens if the x is negative, the square root of -1, etc., etc. Just watch out a few little important principles as well if you go to a sheet of paper here. I'm going to write this down because so many people misunderstand this. You see, the important principle, the square root of Mbuyi, he's standing there. If he's under there, if he is sad, then the square root of Mboyi is non-real. Okay, watch out. Okay, if he is happy, is he's happy, or he's maybe neutral, or he's got a zero expression, or a zero face. Look at, he looks at you, this is happy. Yeah, I'm happy. Or, those kind of neutral dudes. Okay, all right. Or he's very sad, his girlfriend's left him or something. Okay, what happened is then we talk about the square root of Mboyi being real. That's important. Okay, so watch out for that. And the other thing, very important, if you look at this quickly, if I show you something here, if you take the square root of 9, okay, now I know some books will say plus minus 3. The square root of 9 is 3 because 3 times 3 is 9, or minus 3 times minus 3 is 9 as well. So why can't the square root of 9 be plus or minus 3? Well, the root of 9 is plus or minus 3. However, in terms of what we call the principal root, the principal square root, it's defined as positive. So for our purposes, we're going to say the square root of 9 is 3 and not plus minus 3. Okay, very important that the square root of 9 we treat it as the principal root is not going to be plus or minus 3. Okay, so be careful with that. Let's look at an example quickly. This one's a lovely exam question. It says there, for which values of x will the expression x squared minus 2x be, let's see, real, and for which values of x will it be non-real? Okay, now people, this is a kind of a sneaky form of inequalities. Have a look at this. If we write down the expression on paper, we've got the square root, and Mbuyi is x squared minus 2x. We are going to look at him. He's a dude underneath the square root there, okay? And because the x is variable, he could be x squared minus 2x, could be very happy, or it could be, in fact, very sad as well, okay? Or it could be equal to 0. Okay, now watch this. Let's go and have a look at it. Now, we say, this is so important, this is real, okay, if the dude under the root, if x squared minus 2x is bigger than or equal to 0. Remember, real, the square root of x is real if the x is bigger than or equal to 0. Very, very important. It's got to be bigger than or equal to 0. Okay, now what have we got? You can't square that, by the way. You can't just square that and drop the root. You've got to state that this is real if that. Now, inequality. So what do we say? Therefore, factorize it beautifully, not a problem there. Okay, parabola method again. Let's have a look here. If we draw the parabola, what a pleasure. Now again, it'll be 0 and 2 and closed dots because we're cutting. Remember, this is cuts the x-axis, and it's above the x-axis. Okay, very important. So that's important. It's above and cutting. Okay, so where's the parabola above? It's to this side and this side. So it's x less or equal to 0, or x is greater than or equal to 2. And that's such an important principle because now, I mean, if you pick any value less than 0 or any value greater than or equal to 2, in fact, the expression will be real. Let's test it. For example, if you take a value, let's pick a value, let's say smaller than 0. Give me a value smaller than 0. Let's see what it is. What do you think? Let's try -2. So let's have a look. Here's our expression. Okay, x squared minus 2x, and we're saying that for all the values of x that are less than or equal to naught, or x than greater than or equal to 2, this is going to be real. Well, let's see. Let's try x equals negative 2. Okay, now substitute it in. Negative 2 squared minus 2 times negative 2. Well, what does that come to? Let's see. Okay, this is going to come to the square root of 4 plus 4. And guess what? That's the square root of 8, which is extremely real. It's positive. That's very real. But now, the other question was, for which values of x would it be non-real? We'll check this. Here we go. The root of x squared minus 2x, if we look at that, is going to be non-real if x squared minus 2x is less than naught. And then if you factorize that and you do your parabola, it's going to be like this. That's naught and 2. And where's it below? Naught less than x less than 2. Any value in between there. So guys, watch out for that. And from me, Mark Phillips, your maths dude, we'll see you next time for some more wonderful mathematics. See you around. And Matrix Uploaded rocks. See you soon.